Okay, I'm going to do a little practice before we actually see if you can handle this problem. And that is finding the sixth roots of 1. Sixth roots of 1. We're going to find the 2 second roots of I. All right, so we got I. And Z is I. What does that mean? It just means that's my name for my complex number. And then what do you usually put in here to put it into rectangular form? 0 plus I. That's my Z. And if I'm going to be taking the 5 fifth roots or the 2 second roots or the 3 third roots, they have to tell you which root to take. It's not like any number, like this doesn't naturally have a number that goes with it. You just decide what you want. Do you want the 7th roots of it? Do you want the, well, I decided on this 2 square roots, the 2 second roots of this. So I'm going to say that Z squared is this, and then I'm going to take the second root of that. Now, I think it's actually a little more confusing to actually have that Z squared at the front. So let's just call it 0 plus I. Now, the first thing I got to do is find cis form of that. So would you please make a little sketch of where this is and figure out what its R and its theta are? Then you'll have cis form of it. I'll pause for a second while you figure out cis form of that. All right, so here's how you would have gotten cis form. You'd say, well, it's 0 to the right or left, and it's up that, which is 1I, so I'll go up 1. Notice that is not an I, that is a distance of 1. It's on the YI scale. Okay, and now that's dot right there. That dot is the answer. I'm just forcing it to sort of look like a triangle because normally we make triangles, but in this case we can't. So that's actually kind of cool. These are actually quicker then. So I know the angle is this, which is pi over 2. And I know the R is 1. And what do I need between them? 1 cis pi over 2. Raise your hand if you had it right. Good. Now if I'm going to find the 2 square roots of it, then I just have to take the square root of it. Is that right? No, I just squared it. Square root of it is what? 1/2 power. Okay. Now, do you remember that with de Moivre, it's all about de move of the exponent? So this has to go down here and will be 1 to the 1/2 power, which is, by the way, what? 1. And then the 1/2 also has to move down in here, and this becomes pi over 4. Okay, so I now have 1 to the 1/2, which is 1. I'll put it in just so you can see where it's going. Times, that's not really, well, it is a times, but don't have to put the times there. Cis, and then I need the 1/2 times the pi over 2, which makes it pi over 4. But, and this is really important now, we have to also include plus 2 pi n. Why? Because we are looking for multiple answers to this. So plus 2 pi n, or k, sometimes people use. But if I just do this, I've already kind of missed the train. I already missed that little power coming down. Remember the power came down and went on this? So I now have to do the power on this also. Okay? Or you could do the power in front of the whole thing, but I already multiplied it times the pi over 2. So I'm going to put the power right there, and now I'd have the 2 canceling the other 2, and it's just pi n. Now just think about this. That means I'm adding pi, or if I put in a 2 here, I'm going to add 2 pi. Or if I put in a 3 in the end, I'm going to add 3 pi. That's what I'm going to add each time. Not 2 pi, just pi. Why? Because this 1/2 acted on the plus the 2 pi n and made it just pi. So I'm going to simplify that down one more time and say 1, because 1 to the 1/2 is 1, cis pi over 4 plus the 2's canceled, pi n. Now, that is not even an answer yet, because it's got that n in there. So now you go n equals 0, n equals 1, and just for the fun of it, I'd like you to figure out n equals 2. I know we were only supposed to find the 2 roots of it, but I want you to see what happens firsthand when you do too many of them. All right, so we're going to stick in 0. That goes here. And that makes it really easy. 0 pi is just 0. So it's 1 cis pi over 4. Can you just leave it like that? Nope. You have to multiply it out and get your coordinates in x, y, I form. This is polar form of the answer, but you need the rectangular form. Who's got the next one? 1 cis of what? 5 pi over 4. Why? Because you stick in a 1 there and it becomes pi, which is like 4 pi over 4. And that way, when you add another 1 pi over 4, you got 5 pi over 4. Now, if we were doing like a whole bunch of roots, let me show you a shortcut that's really kind of cool right here. Do you get the only difference between this one and this one is that you added 4 pi over 4? Do you get that you could do that again? So just the next one's got to be 1 cis. And instead of 5 pi over 4, I should add what? 4 pi over 4 makes it 9 pi over 4. One little flaw there. And on the last one too. Can't be greater than what? Pi. So we got to figure out where 5 pi over 4 is and rewrite that with a negative power, or negative, sorry, angle. So if it's 5 pi over 4, that's right there. That's the same as negative what? 3 pi over 4. And it does make a difference because you're not allowed to leave something in this form that way. Negative 3 pi over 4. Now, interestingly enough, it will actually work if we take this one and add 4 pi over 4 to it. Watch, if we have negative 3 pi over 4 plus positive 4 pi over 4, it gives me pi over 4. It was 9 pi over 4. Just to clarify, 4 pi over 4, 8 pi over 4, 9 pi over 4. It's in the exact same spot. 1 pi over 4. I should have gone a little higher. Okay, so moral of the story. This little blue line, this little shortcut thingy is kind of cool. You take this and you just have to add 4 pi over 4 to the original. The only problem is that sometimes you go over pi, in which case you have to simplify it to a, or not necessarily simplify, but make it into a negative angle. All right, how many of you actually have the x and y coordinates already? Okay, then you need to do this. This is a R2 level skill. Take that and multiply it out. And figure out what it comes out to in rectangular coordinates. Do that for all 3 of them. Instead of me doing a separate problem to practice that, why don't you use this as your practice of, do you know how to multiply out cis form and get it to rectangular? Yes, sir? Once you're done with this, you'll have the x and the y, and yes, they can be plotted, and yes, they do something cool. But let's save that until we're done actually figuring out what the x and y's are. Yes. Pause for a second here. Okay. I'll call on some people to figure these out. Mr. P, what did you get for the first one? Yes. X and Y, I. So if it was like 1 plus 3I, whatever. Apparently you haven't done it yet. I'll have you do that, and I'll come back to you. All right, Mr. O, what did you get for the second one? Cosine I sine of negative 3 pi over 4.
Negative 1 over square root of minus I over square.
Minus what?
I over 4 plus negative I over square root.
Either way is fine. I over square root of 2?
Yep.
All right. Can anybody verify that answer? Excellent. Okay. Then the third one. Mr. B. Back corner.
1 over the
So this is, again, just for the people that have the lost look on your face, it's just cosine of pi over 4. You've been doing that forever. Where's pi over 4? It's right here. And if this is a pi over 4, then this is a 1, 1 square root of 2 triangle. And the cosine of that would be adjacent over hypotenuse 1 over root 2. Okay, so go ahead. Finish it off. 1 over root 2 plus what? Excellent. Now, how would I know that that would work? What could you do to it? What's the point? We just found the two what? Two what kind of roots? Two square roots of I, which means if you square these things, as you multiply this times itself, it will come out to the original I. Okay, if you undo the square root thing that we just did and you take your answer and you square it, this squared will equal I. So you found the square root of I, and there were two of them, that and that. Okay. Do you understand that process that we just went through? All right, then go to this slide there, and they were asking you for the what roots of what? Sixth roots of 1. And it's already written in XYI form, but you need to change it to what? Cis form. So figure out what cis form of this is first. I'll pause for a second while you do that. Okay, so that was way more time than you needed to find cis form for this. It's over 1 and up 0, which means it's a dot right there. So if I was going to give r and theta directions to get to it, r is 1 and theta is an angle of 0. So it's r cis theta, and we've just figured out that the radius was 1 and the theta was 0, 1 cis 0. Raise your hand if you got the same thing as me. Good. Now, hopefully you've embarked on the process already, but if you haven't, put this plus 2 pi n, then put it to the power of what? 1/6. The only reason we're throwing that plus 2 pi n there is because we want multiple answers, and that'll help us as we make n equal 0, n equal 1, n equal 2, n equal 3, holy cow, n equals 4, and n equals 5, and then that'll give us 6 answers. And you need to find the XYI form of each of them. That's the kind of thing you'd have to be able to handle for the test. This is complicated stuff, and it's not, I don't think it's that hard. It's just really a long process to get all 6 answers. Okay? I want you to find all 6 answers, and don't leave them in cis form. You gotta multiply it all the way out and get rectangular form. Yes, ma'am.
For the in cis form where it's the 0.
Yep.
Why should that also be pi?
Okay. The angle that we were looking at in this, would you agree that my dot was right here?
Yeah.
Okay. We always start there. If it was going to be anything besides that, pi, by the way, would be if it was over here.
Oh, right.
Okay. If it was going to be anything else, it could be 2 pi. But if you're picking between 2 pi and 0, always pick 0. Okay? All right. But I'm glad you asked, because otherwise it'll just would have been bothering you until you finally eventually got around to asking. So, all right, I'm going to pause for a minute while you try this. This requires some grinded out effort. Okay? I'll pause while you give that a shot. Okay, from my quick cruise around the classroom, most people seem to know what they're doing, but there's a few that aren't doing it right. So let me help you get started on the first one. You should be doing 1, which is put to the 1/2 power, by the way. This is Demov at work. It's all right. Thank you. I was talking in general form about the 1/2 before, but this is the 6th root. So we're going 6th root, thank you, and the 6th root. So that 6th root of 1 is just 1. I could write 1 to the 6th, but it'd be a lot cleaner to just Right, 1. Cis, and then this is important. It's 1/6 of 0 plus 2 pi n. That's your general form for all your answers. In this case, I replace the n with a 0. That becomes a 0. And then that last plus 2 pi disappears. And it's just 0. So it's cis of 0 times 1/6, which is still 0. So it's 1 cis 0. And what's rectangular form for that? 1 cis 0. If you haven't got this one memorized yet, 1 cis 0 is just 1. There. It's back to rectangular form. And it makes sense that 1 would be one of its roots, because 1 times 1 times 1 times 1 times 1 times 1 times 1, I think that was 6 of them, or 5, whatever it was anyway, times 1 gives you 1. So it works. All right, this next one is going to be identical to this one, except you're going to put in, instead of putting in 0 on the next line, you're going to put in 1, and you're going to simplify it down, and hopefully you remember that little shortcut I told you about figure out how much your angle changes from this one to the next one. And then you won't have to redo a gigantic problem every time. You just add the right thing each time. I'm not going to tell you what it is, but let's say it was add pi over 3 each time. Then you just add pi over 3. Whatever the answer was before, add another pi over 3. Whatever the angle is next, add another pi over 3. All right. So see if you can figure out the 6 answers. And remember, I want them in rectangular. They're going to look like that when they're done. Except some of them are going to be like root 2 plus root 2i. They're going to have both components, both real and imaginary components on most of them. So get your rectangular answers when you're all done. They should look kind of like this original, actually. A number and then however many i's. And there'll be 6 total answers. I'm going to pause for a second. Let you give that a shot. So here's how this one would go. If I put in a 1, now it's cis. Notice me dropping the 1. 1/6 of 0 plus 2 pi times 1, which is 2 pi. So now it's 0 plus 2 pi, which makes it 2 pi. 2 pi times the 1/6 makes it 2 pi over 6, which makes it pi over 3. Oh my gosh. I think it was adding pi over 3 each time, wasn't it? How many of you got cis of pi over 3? Okay, good. Notice what the angle was last time was 0. Notice the angle went to pi over 3. Looked like it went up pi over 3. Get what I'm saying? So then I bet you anything that you could just add pi over 3 again next time. Did anybody already calculate the next one? Did it come out to cis of 2 pi over 3? All right. Noticing something there? What's the next one going to be? Cis of 3 pi over 3, also known as pi. See how that would be a lot faster? All right. You can do it the old-fashioned way and stick a 3 into this formula right here. And you'd have 6 pi, and then you multiply by 1/6, and you get pi. It'll all work, but I recommend this way. But this next one is going to push it over pi. What's the problem with that? Can't have numbers bigger than pi, so you got to rewrite that as a negative. Okay, but if you're actually getting the cosine I sine of it, it'll actually work out. But you better not leave an answer like that if it was the answer. Okay, so 4 pi over 3, just so you know, there's 3 pi over 3 plus another pi over 3. Makes it like that, also known as negative 2 pi over 3. So, and the cool thing about taking the time to change that is now you're good for the last one. You can just add another pi over 3 to it. Negative 2 pi over 3 plus a pi over 3 is going to make it negative 1 pi over 3. Cis of negative pi over 3. Okay, now what all these cis things really mean is cosine I sine. So, Mr. P, that one, the second one. Did you do it or not? Oh, you didn't get pi over 3? Oh, okay. What did you do? Curious. What did you get?
So I just got
So you're saying you got a 1 again? So you just kept getting 1 every time? Okay. All right. You see how that's kind of not 6 different answers? All right. Good. All right. We're going to go to Mr. B in the back row. The second one. When you did cosine of pi over 3 plus I sine of pi over 3. Okay. This part's 1/2. Keep going. I root 3 over 2. Raise your hand if you can verify that one. Okay, good. I wish there was a shortcut way of giving you these, because there's a shortcut way of doing these we showed you, but there's not a shortcut, as far as I know, of getting these rectangular coordinates. We got this, which is technically plus 0I. All right, yes?
So it's going to be the same numbers each time, except it's like whichever direction.
Interesting. So are you saying we could go like this
And then if you look at
every time?
through,
Just hold on. Are you right? Is she right about this? Is that the same, those every time?
except
Cool.
for pi, you get
Oh,
for pi. Pi is 0.
okay.
Pi is 0.
All right. So we'll have to, we can get a lot of them from this at least. So I'm going to make this what's called an infinite cloner. Where is it? There it is. So then I can keep dragging this down for each of my, oh, drag another one down here. My rectangular forms. But which one is it that turns into? All right. So this one doesn't actually work. It turns into what? All right. See, again, it's pretty tough to like. It's cool that you're right. That there's a directional piece of this, and I'm going to show you why in just a second. And then what were these numbers? Should this be negative now, or?
Yeah. So then if you look at the diagram of like where that angle is,
Awesome.
like cosine's negative and then
Okay, so hold on. So what should be negative next?
4
4 is where they're both negative?
negative, and this 5 has square root of 3 over 2.
And that part's negative. Okay. All right. So this brings up a really important point, and that is, what do these look like when you graph them? You may not have been thinking about that, but put it on your radar, because it's something that makes this kind of like helps you understand more about it. There are 6 answers, right? These 6 things are going to give you 6 answers. Once you put the dots on the graph for each of them, do you get that it generally kind of makes a circle? There's one here. That's for 1. That's this guy. There's one here at -1. Then there's over 1/2 and up root 3 over 2, which comes out to about 0.8. So over 1/2 and up about 0.8. Let's say that this was going to be where 1 was. So we go over 1/2 and up about 0.8 is like right there. And then you go right about here. And I want you to just figure out what is happening. We're making a hexagon. In fact, it's a perfect regular hexagon, which means all the sides are equal length. So if you had an evil dictator tell you, I'm not letting you leave the cell until you draw me a perfect regular heptagon, 7-sided shape. They're very hard to make. Hexagons aren't that hard. So it's basically just, octagons aren't that hard. They're like a stop sign, right? But a 7-sided shape that's perfect with all the equal angles and all equal sides. If you could graph this, if you could graph all of these, you'd have all the dots that are perfect. All you'd have to do is connect the dots. How would I do the 7 roots? It's exactly like this, wouldn't it? Except you'd be putting it to the what? The 1/7 power. And you'd only get 7 answers. Okay. So, just in case an evil genius ever locks you in this cell, you got one more thing that you'd be able to do to get out of it. Mathematical saw. You can never leave until. All right, that's awesome. So, I have gone through now with you a couple times how to find these roots, and I feel like most of you are good with it. You'll find out tonight, I guess, if you're really, really good with it, because your homework for tonight is to do ones just like that. I'm going to reiterate what you were assigned before, which you are now fully responsible for. You were already. I thought you could have done it, but I got a lot of feedback from kids that they were lost, so I decided not to grade it today. So I am going to have it on the docket to potentially grade tomorrow. So here's, nope, that's not it. I assigned you day 5, which is right there. I assigned you this one. If you haven't already done it, first you put it in sys form. And all you had to do on this one was get it in sys form and then do demov on it, which means drop that 6 power down onto the sys form. Okay. Then I assigned you this one, the 2 square roots of. Oh, come on. There's only 2 answers to it. I just showed you the process. You should absolutely have been able to do that. But if you weren't before, get it done for tonight. And then I'm assigning you 2 more. And it comes from the next day's assignment right here. Especially since I am in my class, I'm going to pause for a second. All right, so do number 72 and sketch those points. There's 3 cube roots. The dots will all be equidistant apart, which makes it a what kind of a triangle? A perfect equilateral triangle. And all the angles, therefore, you will be making perfect angles too. Now, it might be hard to actually know exactly where square root of 3 is on a graph, for instance. You can use your calculator if you need to figure out the decimal for it, so you can at least be pretty close. Then I want you to do this one. The 9 roots of -1. But do you get, once you get what angle you're adding, you just have to keep adding that same angle. I told you that shortcut. Like on the last one, we figured out it was just pi over 3s. You keep adding. Just keep adding pi over 3 each time, or whatever this one turns out to be. How do you figure that out? You have to go through the beginning to get that process to know what's being, what it's, and mainly it boils down to sys form. Once you know the sys form of this, you know the angle. Once you know that angle, you know you're going to do plus 2 pi whatever, and then you're going to have a power of the 9 roots, so it's a 1/9 power. I could actually tell you right now what you're going to add each time, except that you'd want to have you'd want to make sure it has a common denominator. So in other words, if I say to add 2 pi over 3 each time, but you're actually in 12ths, it'd be a lot smarter, instead of adding 2 pi over 3, if you really want the answer to be in 12ths, because your other angle is in 12ths, then you probably should go like this and add 8 pi over 12 each time. See what I mean? All right, but if nothing else, do like the first 3 of them. N0, n equals 0 is your first one, n equals 1 is your second one, n equals 2 is your third one, and figure out if you can figure out what they're adding each time. That's just the simple way to do it. All right. Oh, and it does say to sketch the points on a complex graph. I am asking you to do that one as well. It's not too tough. These are estimates, and it is kind of tough to draw a 9-sided equilateral shape. So that'll show you that once you've got the directions, like what points to graph, it's not that hard. It's doable. Okay, so yes, you have to graph that one, and that's it. That's all I'm assigning. Just those 2 problems, and make sure you graph both of them. Can't say that I assigned too much. All right, so that gives you an extra day to get done. Be ready to be grading tomorrow. I don't want to hear excuses. I gave you a really easy assignment over the weekend, but it was a little tough to do the math of it, but I only gave you 2 problems. Now I've only given you 2 more problems. You have no excuse to not have this done well tomorrow. Okay, that's all I have for you for today.